Next, we have postulates or axioms. Usually we're going to refer to them as postulates. And what these are is they're just statements that are accepted as fact. So you can't disagree with them. They're true no matter what, and there's no argument. That's just the way they are. So our first postulate states that through any 2 points, there is exactly one line. So if I put 2 points here, let's call it D and E. If I draw a line, not the best at drawing straight lines, but ooh, that wasn't too bad. There's only one line that's going to go through those 2 points. There's no disputing that. That's just fact. So it is a postulate. The next postulate says if 2 lines intersect, so let me draw 2 lines intersecting, something happens at their intersection, there is exactly 1 point. So in this case, let's call it point Z. And again, we use capital letters for points. Now in the book is going to assume that you know this now that we've stated it, and they might not put a point where the lines cross or intersect, but it's still assumed that there is a point there. So we could have this, 2 lines are intersecting, and then we could call this point B. So even though there's not a point where the lines intersect, it still is a point, and its name is B. All these technicalities, I know. Postulate 3 says if 2 planes intersect, then they intersect in exactly 1 line. This is not as easy to draw as it looks like. I'm going to try it. So there's 1 plane. Let's call this plane B. And then we have another plane. Okay. Now, so in this case, the best way to think of it, and let's call this plane D, is 2 pieces of paper intersecting. When 2 pieces of paper intersect, they're going to touch at 1 spot, and the place that these 2 planes are touching is the black line. Okay? And again, it's only 1 spot, and it's exactly 1 line. And again, we name a line by 2 points, so let's pick some points. Let's call this, use pink, point A and point C. So we would say these 2 planes intersect at line AC. And again, planes go on forever, so this line would go on forever. You can kind of think about 2 walls. 2 walls in this classroom. If you look around, or at your house, if you look around, your 2 walls, they intersect at one and form a line. And if the walls never ended, if your house was bigger than the earth, it would keep going on and on and on forever and make a line. So number 4. The last postulate says through any 3 non-collinear points, there is exactly 1 point. And again, let's pick 3 points. Non-collinear means they are not on the same line. So in any time points are non-collinear, they're going to be able to make a triangle. So if I were to connect these 3 points, it would make a triangle, so that means it's non-collinear. They're not on the same line. So we'll call this A, B, and C. And this is saying that these 3 points have to be on the same plane or the same piece of paper.